Hey guys, what's up? This is Extreme Zappers. So first of all, just a quick heads up. It's super late right now, like really early in the morning, so I'll try to keep my voice down a bit. Hope that's okay. So anyway, in this video, I just wanted to talk a bit more about the shorts I uploaded recently, and I'm going to go into more detail. So yeah, but before going directly into the shorts, uh, let me start with a bit of the background explanation first, okay? So today, we're going to talk about how to solve limits that result in the indeterminate form of 0 over 0. This kind of form, it's called an indeterminate form because the value isn't immediately clear. The main topic here is methods for dealing with limits of this kind of type. So yeah, we're going to talk about how to approach uh, this kind of limit problem. Actually, yeah, this. But before we really get into it, let me give you a bit of background on the problem we will be dealing with in this video. So actually, uh, this problem actually comes from a Korean high school exam. It's not from the national CSAT exams, though probably just a regular school test. Uh, to be honest, actually, I don't know the exact source. I just kind of came across it somehow. Anyway, it's definitely a high level question made for Korean high school students. Now, the key thing here is this. In the Korean high school curriculum, L'Hopital's rule is not included. Like, seriously, uh, it's something you only learn when you get into a science or engineering major in college during first year calculus. So, yeah, the rule is completely outside the high school syllabus. So, in conclusion, L'Hopital's rule isn't in the official Korean high school maths curriculum. But still, a lot of students use it anyway, kind of like a shortcut to solve problems faster. Actually, this has been going on for quite a while. Students have been quietly using this trick because honestly, Korean math exams are super time pressured compared to other countries. The time limit is really tight. Plus, it's not really about showing full solutions most of the time. You're just picking the right answers out, like A, B, C, or D. So, from that point of view, using L'Hopital's rule gives you a huge advantage during the exam. And you know how intense private education is in Korea, right? Like academy schools, tutors, like home tutors and such like that. Uh, they teach students how to use this rule, even though it's not in the official curriculum. Only just because it helps them solve problems way faster. So students end up using it a lot even if it's not really allowed. Now, teachers, the ones actually writing the questions, right? they totally get this. So they know students rely too much on L'Hopital's rule. But that's not the intention behind the curriculum, right? So they started thinking, let's write questions that can't be solved using L'Hopital's rule. Let's make sure students are tested only on what they are actually supposed to know in high school. And honestly, I think that's how this problem came up this year. They really put some thought into it. Alright, so that's the background out of the way, okay? So now let's actually get into how to solve these kinds of problems. I'll start with an example since that's usually the easiest way to understand things. So let's say we have this limit as x approaches -1 of x squared plus 3x plus 2 divided by x plus 1. So first, try plugging in the value that x is approaching, which means just substitute x equals -1 into this fraction. So what you get is the numerator is just this, right? 1, -3, +2, which equals 0. And denominator is -1, +1, which equals 0. So 0 over 0. This is what you get. Yeah, that's an indeterminate form. So what are we trying to do here? Well, the goal is to find the actual limit of this rational expression, the fractional expression, as long as it does converge, of course. So our aim is to figure out exactly what value it approaches. But to do that, we need to get out of this 0 over 0 situation. In other words, we need to simplify or reform the expression. Now, how do we do that? Basically, there are two main strategies I want to talk about. So, the first method, like I mentioned earlier in the background, is using L'Hopital's rule, which again is not part of the Korean high school curriculum. So let's write that down. Method number 1. L'Hopital's rule. Okay, L'Hopital's rule. The second method is the one that is expected within the high school curriculum in Korea. It involves algebraic manipulation. So basically, rewriting the expression to simplify it. So let's call that method number 2. Algebraic manipulation. Okay. So the first method, L'Hopital's rule, right, is something many of us are already familiar with in. So it says that for a 0 over 0 form, you can take the derivative of the numerator and both the denominator separately, and the limit stays the same. So let's actually try applying it to this example. So applying the L'Hopital's rule here, limit x approaches -1. The derivative of the numerator and the derivative of the denominator, right? So it's 2x plus 3, and this is just 1, right? So limit x approaches -1, 2x plus 3 over 1. So now we just applied the L'Hopital's rule, right? And if we plug in the value of x, which is approaching, it's 2 times 1 plus 3 divided by 1, which is 5 over 1, which is 5. So in conclusion, the 0 over 0, that kind of form, goes away, and you get a nice clean number like this. And yeah, this actually gives us the correct limit value. So just to sum it up a bit, in most cases, like 9 out of 10 problems, once you apply L'Hopital's rule just once, or maybe twice, up to twice, you no longer get a 0 over 0 form like this. That means the expression becomes maybe like well-defined or regularized, I don't know. Anyway, right away like that. And when you plug in the value after applying the L'Hopital's rule, you get the exact limit. So it's clean, it's quick, and you get the answer almost immediately. That's why this method is super useful, especially in Korean high school math exams, where the goal is often just to pick the correct answers as fast as possible. But in rare cases, like this problem, applying L'Hopital's rule once doesn't get you out of that 0 over 0 form. Which means you'd have to apply it more than once. And the problem is, for this problem, there's a square root involved in it. And you also have to use the product rule. So the more you apply L'Hopital's rule, the messier the expression gets. Like, way more complicated, right? That's why the L'Hopital's rule doesn't work for this particular problem, since students are under extreme time pressure. This kind of long, messy derivative is just not practical enough. So yeah, for this problem specifically, using L'Hopital's rule is actually really inefficient. The more you differentiate, the more complicated the expression gets. And remember, Korean high school math exams are extremely time pressured. You don't really have the luxury to spend too much time on just one problem. So in this kind of context, it's basically telling you just don't use L'Hopital here. It takes way too long. And this is exactly the teacher's intention. They want you to solve the problem using only what you've learned in the high school curriculum. That's kind of the lesson behind it. Alright, so that's pretty much it for L'Hopital's rule. Now let's move on to the second method, the one that's actually expected within the Korean high school curriculum. So this method doesn't use L'Hopital at all. Instead, we find the limit value by simplifying the expression or manipulating the expression algebraically. And guys, also, just one more thing I want to keep emphasizing. In this video, we are only going to focus on the basics of calculus as taught in Korean high school math. Uh, Specifically, we are talking about the current curriculum subject called Math 2, okay, which only covers things like polynomial differentiation and polynomial integration. So, even when we talk about limits in this subject, it only sticks to functions like polynomials, rational functions, and sometimes square root expressions. Something like root x plus 2. Okay? Which means we're not going to deal with limits involving things like trigonometric functions, exponentials, or logarithms. Those are like called, what is it? Transcendental functions, right? Yeah. And that's beyond our scope here, so we're not going to talk about that. If we go into that, the video is gonna get way too long. So yeah, we're just gonna focus on limits involving polynomials, fractional or rational expressions, and root functions. Alright. Alright, so let me just start with the conclusion here. Within the second method, there are actually three main techniques. It's kind of like subcategories. The first one is factoring. The second is rationalizing. The third one is combining fractions, right? Combining fractions, or also known as finding a common denominator. Okay. So, depending on the problem, you might just use one of these, right? But for slightly more difficult questions, like this, you might need to combine two, like, or even all three of them. Not quite sure, but more than one, okay? So it depends on the specific type of expression you're dealing with in. Alright, so it all comes down to these three techniques. Now, here's something really important to talk about. Whenever you solve a problem, we need to have a clear purpose, right? It's definitely totally normal to ask, why are we even doing this kind of stuff? Why are we factoring or rationalizing or combining fractions? Well, like I said before, the whole goal here is to get out of the 0 over 0 situation. We need to get rid of that. If we were using L'Hopital's rule, that would usually happen automatically. So, like, you differentiate like this, right? And plug in -1, so plug in the value, and boom, you get a real limit value easily, easy peasy. But if we are using algebraic manipulation method instead, right, then what we're really trying to do is this. Let me write it down. Removing the factors that are causing the numerator and denominator to become 0. Okay, so this is the main key idea. So in other words, we want to cancel out the zero causing factors or terms in both the numerator and the denominator. And in mathematical terms, that means we are basically simplifying or reducing the expression by canceling stuffs. That's why we use these three techniques: factoring, rationalizing, or combining fractions. Sometimes, for easy peasy problem, using one of them is enough, and sometimes for kind of a trickier problem, you have to use two or more. And definitely, just talking about it can feel a bit kind of abstract, right? So let me actually show you how it works with a real example. Alright, so let's actually solve this problem now. For this problem, it uses the first technique, which is factoring. Once we go through these steps, you guys should understand why we should use factoring. So, if we take a look at this expression, the denominator, there's nothing to factor there, right? It's just x plus 1. But the numerator is a quadratic expression, right? So there's a good chance maybe we can factor it or not. But this is actually factorable. If we try it, it factors nicely as, let me just write it here, limit when x approaches -1, x plus 1 times x plus 2. Okay? And like this, right? Now, let's pause and try plugging in x equals -1 into this factored form. So, if you plug -1 into x plus 1's, you get zeros, right? But if you plug -1 into x plus 2, you get 1, which is not 0. So, what does that tell us? It means that x plus 1 is the part that's causing the 0 in both the numerator and the denominator. That's a key point. Which means these two are causing the 0 factor. So that's the 0 causing factors. So now, what do? We can cancel out that common factors from both the numerator and denominator. And once we do that, so it's just basically canceling out x plus 1. So once we do that, it's just like this, right? Which means the 0 over 0 is gone, just like what I talked about earlier. Now we're left with just x plus 2. And if we plug in x equals -1 now, we get the value, which is -1 plus 2, which is 1. And that's it. That's the actual limit, the convergence value. And actually, sorry about that, I just realized that I made a small mistake earlier when I was doing the first method. I accidentally plugged in 1 instead of -1 for x. So yeah, the limit value I set was 5, and this is definitely incorrect. So let me fix that real quick. So if you plug in -1 like what we supposed to do, and we get 1, right? Which definitely is equal, right? So this sentence I wrote in the box earlier, that's really the key main idea. So you escape the 0 over 0 form by removing the factor that causes 0. That's the whole point. And to do that, we have 3 methods or 3 techniques. Like I keep saying, it's worth repeating it because it's that much important. So the example we just did was a case where factoring works. But the other 2 methods, rationalizing and combining fractions, also have their own specific types of problems where they apply. So while we're at this topic, let me just go ahead and introduce those as well. Alright, now for the second method, rationalizing. So what kind of expressions does this apply to? Well, usually you'll see something like a square root minus another square root. So something like this. So sometimes both terms have square roots like this, but it doesn't really have to do like that. So sometimes only one does. Alright, so this is not a square root, or maybe this is the only one that has a square root. So either way is fine. Yeah, so that might sound a bit technical when I say it out loud. So let me just show you an example. That will definitely make more sense right away. So, number 2. So, yeah, like this. When limit x approaches 2, root x plus 2 negative 2 divided by x negative 2. So, like what I said earlier, this type of problem has the form of square root minus something. So sometimes both terms are square roots, and sometimes just one of them is square root. So anyway, those all work. So what do we do here? Well, in this situation, we use rationalization. Now, what does rationalizing actually mean? It means you multiply both the numerator and the denominator by the conjugate. Yeah, conjugate, right? So, which in this case would be square root plus something which is 2. So, you multiply both the top and the bottom of this fraction by the conjugate of root plus something. And once you go through that process, it's like magic. The expression just simplifies beautifully. But actually, I kind of rushed ahead here. I should have just done something first, something really basic and essential. Whenever you solve a limit problem, the first thing you should always do is checking the form of the expression before doing anything. Okay? Checking the form of the expression before doing anything. In other words, plug in the x value right away, which is 2. So if we plug in it, root 2 plus 2 negative 2 over 2 negative 2, which is 0 over 0. So just check what happens before you start simplifying, okay? That's the first thing you need to do all the time. So here's the basic logic behind solving this kind of problem. Number 1, always try to identify the form of the expression, which means you plug in 2, okay, into this fraction. And in this case, It's a 0 over 0 form. Once you know that, you basically have two options. Method 1, L'Hopital's rule, or number 2, using algebraic manipulation to remove the zero causing factor and then plug in the value to find the actual limit. So in this case, we are choosing the second method, second option, and since the expression has a form of root negative root, we're going with the second rationalizing method. That's the basic logic flow for the solution. Got it? Okay, yeah. Alright, so let's multiply both the, what is it, a numerator and the denominator by the conjugate and see what happens. So basically, a plus b times by a negative b equals a squared negative b squared. So using this, limit x approaches 2, square root of x plus 2 squared is just x plus 2, negative 2 squared, and denominator, x negative 2 times by root x plus 2 plus 2. The numerator is just x plus 2 negative 4, which is x negative 2. Now, compare this to what we had at the beginning. Earlier, we had 0 over 0 form, but there was no obvious factor we could cancel out. But once we multiply by the conjugate, look what shows up. You can clearly see an x negative 2 term. That's actually the zero causing factor, right? And it appears in both the numerator and denominator. So what did we just do? We transformed the expression to make that hidden zero factor visible so that now we can cancel it out. So again, before the manipulation, we couldn't cancel anything. We couldn't do that. But now after rationalizing, we can. That's the key point. And once we cancel out that zero factor, we're no longer stuck in a 0 over 0 situation. So limit x approaches 2. So it's just square root of x plus 2 positive 2. And numerator 1. Which means we have gotten rid of the indeterminate form, which is 0 over 0. Now just plug in the value, which is 2. Root 2 plus 2 plus 2, right? And numerator with 1. So root 4 is 2, so 2 plus 2. Right? So 1 over 4 is our final answer. Now, from you guys' POV, point of view, the second method, which is the one taught in Korean high school, might seem kind of inefficient because with L'Hopital's rule, which is the method number 1, you don't have to worry about the form too much, right? What you do is you just simply take the derivative each, right, and move on, which is pretty much super straightforward. So it feels kind of like universal tool, right? But the second method, you have to recognize different types of expressions every time, and each one requires a different technique, strategy. Factoring, rationalizing, combining fractions, they all work in different cases. So yeah, I actually totally get it. So from a student's perspective, it feels like more to remember, more to keep track of it. So kind of annoying to be honest, right? But here's the thing, the L'Hopital's rule doesn't always work so neatly, especially in a Korean exam where they give you the time attack. So like some problems, like the one we looked at earlier, just get more and more complicated with derivatives, which is using the applying the L'Hopital's rule. That is why the second method matters. Okay, that's I'm just keep repeating all stuffs again. So especially if you're aiming for a high score, you have to be flexible and able to apply these algebraic manipulation techniques when L'Hopital rule isn't an option. So yeah, that's just the reality of this topic, I guess. And last one, combining fractions. Actually, it's just this. Now, like I showed you in the shorts video, this is a case where you have a mix of a radical function and a rational function. And here's the thing, when you see something like this mixed up, right? You first need to combine everything into a single fraction, which is basically combining fractions, making the denominators same. So that's the starting point. Because whether you're planning to use L'Hopital's rule or do some additional algebraic manipulation, you can't really do anything until the whole expression is written as one whole fraction. So if it's not already in that whole one fraction, in that kind of form, you first should your first step should be to combine the terms and rewrite it as a single rational expression. So this is number 3, all right? And by the way, even though although I didn't mention this in the shorts, remember what I always say when dealing with limit problems, which is step number 1, check the form of the limit. Always, alright? The first thing you should always do. So yeah, before doing anything else, just plug in the x value, which is 0, right? Let's just do that. So it's 0 cubed, right, at the denominator. And in the brackets, root 1 plus 0. Negative 4 plus 0. 4 plus 3 times 0. So this is just 1. And this is also 1. So 1 minus 1 is just 0, right? So looking something like this, which is just basically 0 over 0, right? Got it? Yeah. So yeah, that means it fits into this category, right? So, like what I said earlier, making it into a single fraction is the basic starting point, right? So we just did that first. Then we tried the first method, which is L'Hopital's rule. But yeah, it didn't work out. The expression just got way too messy and complicated after differentiating. So that approach pretty much failed in this case. And something just to clarify something real quick. Uh, Although I listed combining fractions as part of method 2, uh, honestly, I think it makes more sense to treat that this step as a kind of universal pre-step for both method 1 and method 2. So like, no matter which method you are using, if the expression, if the expression isn't always already a single fraction like this, you basically have to combine it first. So that's probably how I should have written it from the beginning, but I just didn't. So explaining it like this really helps me organize my thoughts better too, I guess, yeah. But anyway, I'm not gonna write all of that out in detail because it'll just make things way too long and it takes much more time. So keep that in mind, okay? All right, so we've been talking for almost an hour, right? Right? Yeah. So we covered a lot of important stuffs, and honestly, I think I explained things in pretty good detail. So finally, let's actually solve the problem properly. We're going to use the second method, which was algebraic manipulation, to work through this. So, okay, let me just erase this, right? So, yeah, like I mentioned earlier, combining everything into a single fraction is really just a universal pre-step. So whether you're using method 1 or method 2, if the expression doesn't start out as one fraction, this is the basic, like, what is it, groundwork? Or, yeah, something like that, you need to do first. Uh, so we will leave that part as it is. But now, um, if you look at this form, right, you can probably see, you can probably spot it that it has the root minus something form. Okay, which means it's time to apply our second technique of method 2, which was rationalizing. So we have to multiply both the numerator and denominator by the conjugate, which is 4 plus x times y square root of 1 plus x plus 4 plus 3x. Okay. So limit when x approaches 0. So square root 4 plus x squared, and it's just 1 plus x, right? Now square the second term. And I guess the denominator is really huge. Now, actually, earlier, when we tried the L'Hopital's rule, when I wrote the solution, I expanded the denominator like this. But well, for this time, I'm not gonna do that because we need to preserve the zero causing factor because we're gonna cancel it out later. So instead of writing it in the expanded form, I'm just gonna let it as the factored form. So I'm just gonna keep the expression in factored form. So which means x cubed times y 4 plus x, and then I'm gonna multiply the whole thing of the conjugate, right? Which is 4 plus x square root of 1 plus x plus 4 plus 3x, right? Looking neat and nice like this. Alright, so now the numerator looks like it can be simplified furthermore, right? So let's go ahead and expand everything and try to clean it up. So first, we're multiplying 4 plus x squared with 1 plus x. Let's start by expanding the perfect square part, which is this first, right? So 4 plus x squared times by 1 plus x equals 4 squared plus 2 times 4 times x plus x squared, right? Like this, right? Which is, it's 16 plus 8x, right? Plus x squared. And 1 plus x like this. Now, just keep expanding. 16 is the constant term, and linear term is gonna be 16x and 8x. So if you add these two, it becomes 24x. This is how Korean students actually. So if I just say. So, Korean students don't usually write out every single step while expanding like this. So instead, they think ahead, like where is the linear term coming from, or which part contributes to the quadratic term, like something like that, right? So they mentally track each part and directly write the simplified result. So that's how they save time during the exam, especially under pressure, time attack, right? During exams. So this is the linear term, and where does the quadratic term come from? Um, it comes from 8x times by x and x squared times by 1, which is 9x squared. Alright, and finally the cubic term is only this. Right? So therefore, this equals this. Now the second one is 4 plus 3x squared, which is 4 squared plus 2 times 4 times 3x, plus 3x whole thing squared up. So, therefore, this equals this. Now, what we have to do is we need to subtract this from this. Okay, so if we do that, and wow, something kind of magical just happened here. But actually, this is not really a magic because this definitely is just clearly by the design. So the problem setter just intended it in this way. So what happens is the constant term, linear, and the quadratic term, they all just disappear. They are all eliminated. And what's left? Only x cubed is the leftover, which is the exact factor that causes the zero. And that's the one thing left behind, which means now we can finally cancel it out. Which means this whole thing is just x cubed. And since definitely x is approaching 0, so this is the 0 factor, which means we need to get rid of that, so cancel out that. And if we substitute, so plug in x with 0, and if we simplify this, four plus 4 is 8, which therefore is 1 over 32. And this is our final answer. So, in the end, we were able to solve a problem that was really tough to approach with L'Hopital's rule, but by using the second method, which is the algebraic manipulation, we solved it and we got the convergence value as 1 over 32. And what's the key takeaway? Exactly. Identifying the factor that causes 0 and canceling that out and then plugging in the value leads us the limit value. Actually, of course, this method only works under the assumption that the limit actually converges. I mean, in real analysis, limits don't always have to converge, right? That's the basic logic. But in Korean high school math curriculum or exam papers, they almost never give problems where the limit diverges. I guess, yeah. Why? I honestly don't really know, but in theory, they could include options like infinity or the limit does not exist among the 5 like multiple choices A, B, C, D, E. So you just pick one of the choice and you pick the answers like that, right? But in practice, I've pretty much never seen that happen. So, yeah, the system tends to assume the limit when it converges, and we basically focus on finding the exact value that which it approaches. And that's why this method works so well in that kind of context. And anyway, thanks so much for watching this really long video. We went pretty much deep on a single topic today, but I hope it gave you a clear understanding of how Korean high school math is structured and taught. Please put likes on it if you like this video and hit the subscribe button, and see you in the next video.